For anyone unaware that this is an image of Neptune, it might easily be mistaken for a glowing exoplanet surrounded by bright, narrow rings. The James Webb Space Telescope, JWST, has captured an extraordinary view that also reveals Neptune's faint dust rings, visible in unprecedented clarity. Thanks to Webb's stable and precise imaging capabilities, scientists can now analyze these fine dust rings located very close to Neptune for the first time. Neptune, classified as an ice giant, differs significantly in internal composition compared to other gas giants like Jupiter and Saturn. It is richer in heavy elements and likely possesses a solid core. Traditionally, we recognize Neptune by its deep blue hue, as shown in Hubble Space Telescope images. However, in this near-infrared image taken by Webb's NIRCam, near-infrared camera, operating in the 0.6 to 5 micron range, methane gas absorbs so much red and infrared light that Neptune appears almost dark, except in areas with high-altitude clouds. These methane ice clouds manifest as bright streaks and patches, reflecting sunlight before it gets absorbed by the surrounding methane gas. Additionally, a faint brightness encircling Neptune's equator could indicate atmospheric circulation patterns driving the planet's intense winds and storms. This is the first time such features have been visible, providing researchers with a treasure trove of material for years of analysis. While these observations have answered some questions, they also raise new ones, such as why Neptune's rings shine so brightly in Webb's images, despite appearing faint in earlier ones. Saturn's rings and moons. Saturn's rings also hold mysteries. Their complex structure and extended history of development have fascinated scientists for decades. Some of Saturn's rings are believed to be remnants from the early solar system, billions of years old, while others are relatively young and constantly evolving. Thanks to Webb's infrared technology, the intricate details of Saturn's ring system can now be observed more vividly than ever before. The rings consist primarily of a mix of ice, dust, and rock particles. Each component provides clues about the formation and evolution of Saturn's ring system. The planet's moons, especially Enceladus, play a significant role in maintaining the ring's dynamics. Enceladus actively contributes to the rings by ejecting water vapor and fine ice particles into space via its ice volcanoes. The interactions between Saturn's moons and its rings are among the most fascinating processes in the outer solar system, offering insights into the formation of planetary systems. Uranus, the sideways planet. Webb has also captured stunning images of Uranus, another ice giant. Known for its pale blue color, Uranus surprises us with its intricate ring system, something previously observed in limited detail. Voyager 2 provided the first evidence of Uranus's rings during its 1986 flyby, and later, the Keck Observatory captured glimpses using advanced adaptive optics. Now, Webb's unparalleled sensitivity reveals 11 of Uranus's 13 known rings, some so bright and closely spaced they appear to merge into larger rings. Uranus is unique because it rotates on its side, tilted at about a 90-degree angle to the plane of its orbit. This extreme tilt results in dramatic seasonal variations, with the planet's poles experiencing years of continuous sunlight followed by years of complete darkness. The image captured by Webb shows pre-summer conditions at Uranus's North Pole, with the next northern summer expected in 2028. In the near-infrared spectrum, Uranus's south pole lies in darkness, far from Webb's view. However, the North Pole features a bright cloud at the edge of its polar cap, along with storm activity extending beyond the cap. Another bright cloud on the planet's left edge further highlights the dynamic weather patterns typical of Uranus in the infrared range. Let me unveil a perspective hidden from view, a planet we've long misunderstood. Finally, the James Webb Space Telescope, JWST, has delivered an image we've eagerly awaited. It reveals a celestial body we thought we knew well, but now see in a completely different light. These groundbreaking images showcase what appears to be Saturn, yet its appearance is so distinct that it could easily be mistaken for a twin of Saturn from a distant star system. Familiar yet utterly transformed, Saturn looks strikingly different. What has changed? Are we now seeing, for the first time, Saturn as it truly is? Could these images unlock the secret of its iconic rings? On June 25, 2023, the JWST offered us a breathtaking new perspective of Saturn. As the most advanced space observatory ever launched, the JWST marks the beginning of a new era in celestial observation. With its unparalleled ability to observe the universe in infrared light, the telescope unveils mysteries previously concealed in darkness. Infrared signals, more precise than other wavelengths, reveal details invisible to older telescopes. This revolutionary advancement allows the JWST to illuminate distant and hidden objects, while also offering a fresh look at familiar worlds, like Saturn, in an entirely new light. These insights are reshaping our understanding of the majestic gas giant and answering critical questions about its composition. Unlike the beige-hued images captured by the Hubble Space Telescope, the JWST reveals Saturn in dark, enigmatic tones. Its rings gleam with unprecedented clarity in the infrared spectrum. This is made possible through the near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, on board the telescope. Using specialized color filters, astronomers can highlight unique planetary features that remain hidden in visible light. These filters not only create stunning visual representations but also serve as powerful scientific tools, unlocking new secrets about Saturn's structure, composition, and atmosphere. The scientific community is buzzing with excitement over the discoveries and potential breakthroughs the JWST brings. Even amateur enthusiasts are marveling at the dazzling rings and vibrant hues captured in the images. But what can we learn from these new views of Saturn? And how do they reshape our perspective of the planet and our solar system? Infrared imaging unveils hidden details. Who would have imagined Saturn appearing in this manner? The JWST's infrared sensors penetrate cosmic dust and gas, revealing intricate details. By isolating specific light wavelengths, the telescope gathers detailed data on the chemical composition, temperature, and physical properties of celestial objects. While planets like Saturn do not emit light themselves, they reflect sunlight, and this reflected light carries unique signatures. These signatures offer a wealth of information about a planet's makeup and atmosphere. Although Saturn is considered well studied, there is still much we don't know about this gas giant. Landing probes on such planets is impossible due to their intense atmospheric pressures. When NASA's Cassini spacecraft plunged into Saturn on September 15, 2017, after nearly 20 years of exploration, it transmitted invaluable data for a brief moment before succumbing to the planet's harsh environment. Thanks to the JWST's infrared technology, scientists can now explore aspects of Saturn that were once thought to be out of reach. Each image sent back is another puzzle piece, helping us better understand not only Saturn but also the broader mysteries of the universe. Surprising observations of Saturn. The latest JWST images depict Saturn in dark, mysterious tones, starkly different from prior observations. Even researchers were surprised by how dim Saturn appears in infrared light. One intriguing observation is that Saturn's northern hemisphere, emerging from a 7-year-long summer, is much darker than expected. Scientists believe this is due to methane in the atmosphere, which absorbs nearly all light at certain wavelengths, giving the planet its shadowy appearance. Another fascinating feature is the glowing edge of Saturn's atmosphere visible in the images. This could indicate methane fluorescence, where atoms absorb light and re-emit it at different wavelengths. These phenomena provide scientists with ample data to analyze, sparking new theories and raising fresh questions about the planet's atmospheric processes. Saturn remains one of the most complex celestial bodies, and the JWST promises to deepen our understanding of its atmospheric dynamics. The mystery of Saturn's rings. Why do Saturn's rings shine so brilliantly in the JWST images when other observations have shown them in paler hues? The rings are composed of a mix of ice, dust, and rock particles, each with its own story to tell about the formation and evolution of Saturn's ring system. Some parts of the rings are ancient, possibly dating back billions of years to the early days of the solar system, while other structures are relatively young and in constant flux. Saturn's moons also play a critical role in the dynamics of its ring system. Enceladus, for instance, contributes to the rings by ejecting water vapor and fine ice particles into space through its ice volcanoes. These interactions between the moons and the rings are among the most extraordinary physical processes occurring in our solar system. They provide key insights into the evolution of Saturn's rings and may even hold answers to broader questions about the solar system's formation. Expanding our horizons. The JWST is much more than a telescope. It's a gateway to new scientific dimensions, helping us tackle long-standing mysteries about our solar system and the universe. Each image not only brings answers but also raises new questions. For instance, why do some rings shine more brightly than others? How have Saturn's rings evolved over billions of years? These insights not only transform our understanding of Saturn but also enhance our knowledge of planetary systems across the cosmos. As we explore further, the JWST continues to astonish us. Its ability to pierce through cosmic dust and unveil hidden wonders is exemplified not just in Saturn but also in other celestial objects. For instance, Neptune, the most distant ice giant, appears luminous and striking in the JWST's view, surprising researchers with its double-ring system. The discoveries made by the JWST are a testament to humanity's relentless curiosity and technological ingenuity. Saturn, with its shimmering rings and enigmatic atmosphere, is just the beginning. The universe holds countless secrets waiting to be uncovered, and the JWST is our key to unlocking them.